Today we're going to talk about the properties of logarithms. We're going to look at three different properties and explain how they're used to rewrite logarithms. The first one is called the product rule. You don't necessarily need to remember that name, but this is the first property of logarithms, and it says that if you have a log of two things, they're being multiplied together, in this case m times n, you can split it up into two different logs by using addition. Now just so you know, I'm going to be using common log most of the time in my examples, or at least in my properties, but these work for any logarithm. Natural log, log base 3, log base 11, anything, any log these hold true for. The only thing is you have to make sure you stay in that log, whatever you start with. So log base 3 has to stay log base 3. Natural log has to stay natural log. So just as an example, let's say we have log base 4 of 7 times 5. What this property allows you to do is split this into two, say log base 4 of 7 plus log base 4 of 5. And that's it. It's that simple. There's not a whole lot complicated there. So let's just do one more, then we'll look at the second property. This is log of 10x. Again, we have two things being multiplied. 10 is being multiplied by x, so I'm allowed to split this up by using addition. Now there's actually a little bit more simplifying we can do on this one. If you recall, a common log, one where I don't write the base, has an understood base of 10. And if I have base 10, if this number and this number match, this whole thing just cancels out, and it'll actually just be 1. So that would be my final answer. So you may find sometimes some will cancel out that way, and if they do, you should go ahead and do that. You should simplify them all the way. So that's the first property. That's called the product rule. The second rule is called the quotient rule, and you can probably guess what it does. Just think about it this way. If I'm allowed to split up multiplying by using addition, then I'm going to be allowed to split up dividing by using subtraction. So again, we'll do a couple quick examples of this. Say we have log base 7 of 19 over x. That is the same as log base 7 of 19 minus log base 7 of x. Those are completely identical. You could plug both in your calculator, you'd get the same results. Just two different ways to write the same thing. One thing I did want to note is you're allowed to go either direction with this. They could give you this and ask you to find this, or they could give you the right side and then ask you to find the left side. So this goes either direction. They're equal, so you can use this either direction. You can start with division and move to subtraction, or start with subtraction and move to division. And we'll see some examples of that later on. One more example with this. Let's do the natural log of e cubed over 7. Since we're dividing, we can split it up by subtracting. Again, if you notice, there's something here that'll cancel out. Natural log and e cancel each other out, and all it's going to leave is a 3. So that would be our final answer. Alright, so now we should be ready for the third and final property, which is called the power rule. It has to do with exponents. With logarithms, and this rule only works with logarithms, we can actually move an exponent out front as a coefficient. And again, you can do that either direction. If you have a coefficient, you can move it up as an exponent. If you have an exponent, you can move it down as a coefficient. So that can go either way. Now notice though, the exponent is only applied to what's on the inside. So let's try a couple examples with that. Let's say we have log base 5 of 7 to the 4th. That is the same thing as writing 4 times log base 5 of 7. Or let's say we have, as another example, the natural log of the square root of x. This is important. The way it's written right now, we don't have an exponent. But we can rewrite this so there is one. If you remember, the square root of x can be rewritten as x to the 1/2. Now you can hopefully see that we can move that 1/2 out front, and this would be our final answer. Okay, so now that we know the three properties, let's actually use them to expand different log expressions. Now honestly, at this point in math, there's not a whole lot of usefulness to this except for just as an exercise in helping us understand the properties of logs. But in later maths, particularly in calculus, I know this is actually hugely useful. So for all of these next examples, the directions are to expand the logarithms. And that's been the direction we're going in so far, as we've been expanding. So this is just going to put the rules together in one place. So let's say we have log base 2 of x squared times the square root of y. Now one recommendation I would have for you, when you are expanding the logarithms, always do properties 1 and 2 first, the product and the quotient ones, and then in your second step do the power one, the third one. So I would recommend you do all these in 2 steps. First, I can see I have x squared times the square root of y, so I would rewrite it as log base 2 of x squared plus log base 2 of y, the square root of y. So I've applied actually just the first property in this particular case where I changed multiplication to addition. Now I would do the property that allows me to move exponents. So let's rewrite the square root of y as y to the 1/2, and then our final answer will just be 2 times log base 2 of x plus 1/2 log base 2 of y, because we are allowed, because of that third property we looked at, to move these exponents down front, and that would be our final answer. So when they say expand logarithms, that's what they mean. They mean use the three properties exactly in the direction we first looked at them. Okay, let's look at another example. Let's do log base 6 of the cube root of x over 36 y to the 4th. Like I said, I would first, this is just my recommendation, excuse me, I would first use properties 1 and 2. So I would start by splitting this up. Alright, now this throws some people off, so I want you to pay close attention. On the bottom we have two pieces. We have the 36 and we have the y to the 4th. They are being multiplied together, so a lot of people want to add between the two of them, but that's actually not correct. It's better to think about this as a whole. Think about the whole fraction. As far as the whole fraction is concerned, we are dividing by 36 and we are dividing by y to the 4th. So when I split this up in pieces, I actually need to write a minus sign in front of both of those, because they are both being divided. A simple way to think about this is if you have a fraction, everything on top is going to stay positive, everything on the bottom is going to be negative. If you can just remember that, you won't go wrong. But again, the reason they're both being subtracted is because they are both on the bottom, so we're dividing both of them as far as the entire fraction is concerned. So there we applied the first two properties. Now we'll apply the property that allows us to move the exponents. So I'm going to rewrite this x as x to the 1/3, because that's the same thing as the cube root. And then I get 1/3 log base 6 of x minus log base 6 of 36 minus 4 log base 6 of y. So that's how we expand logarithmic expressions. Now let's go the reverse way. Let's do condensing. So the instructions for the next couple examples are condense into a single logarithm. So we'll be doing almost the exact same thing we were just doing, except in the reverse order. So as a first example, let's do 1/2 times the log of x plus 4 log of x minus 1. So again, we're doing backwards from what we did before. So in this case, I would still do it in 2 steps, but instead of doing properties 1 and 2 first, I would do property 3 first. I would move all coefficients up as exponents. So I would take this 1/2 and move it up as an exponent, and take this 4 and move it up as an exponent. That would give me log of x to the 1/2 plus log of x minus 1 to the 4th. Okay, if you want to rewrite that x to the 1/2 as the square root of x, you certainly can. It's really fine either way. Now I would apply the first 2 properties, at least as much as I have to. Here we are adding, so we can combine them into 1 by multiplying. And we get that. And that's our final answer. So we've kind of simplified. We had 2 logs that had stuff going all over the place, and now we've condensed it into a single logarithm. So I want to try 2 more of these because I find these are a little more complicated sometimes to people to go this direction. So let's look at 3 natural log of x plus 7 minus the natural log of x minus the natural log of 2 natural log of y. Let's do that. 2 natural log of y. Again, I would do property 3 first. Move all the coefficients up as exponents. That will give me the natural log of x plus 7 cubed minus the natural log of x minus the natural log of y squared. Now we'll apply the first 2 properties where we're changing addition and subtraction into multiplication and division. So we get the natural log, x plus 7 cubed goes on top. And if you look, both of these next pieces are being subtracted, the natural log of x and the natural log of y squared. So both of them go on the bottom. So we get x, y squared on the bottom, because both are being subtracted, which means both need to be divided. Again, if you can just remember, negatives are associated with the bottom, positives with the top. Alright, so there's that example. Let's try one more. Let's do 4 natural log of x. Let's do log base 3. Log base 3 of x minus 2 log base 3 of 6 plus 1/2 log base 3 of y. I'm going to go ahead and extend the page here. Remember, when you're going this direction, when you're condensing, I would take care of the exponents and the coefficients first. So I'm going to move the 4 up top. Just move this up here. I'm going to move the 2 up top. Sorry, this is a 6, just in case that's not clear. And then move the 1/2 up top. Okay, now that we've got all the exponents where they need to be, I would combine these. So I do log of, this first piece is positive, so it goes on top. This next piece is negative, so it goes on the bottom. I'm going to go ahead and write 6 squared as 36. And then this last one is a positive y to the 1/2. So it means to be multiplied, which means it goes on top. So that would be our final answer. Again, any positive ones go on top, any negative ones go on the bottom. Positive is multiply, negative is divide. And if you'd rather write y to the 1/2 as the square root of y, that would be fine too.